Hello everyone, and thank you for attending this policy session. I would first like to introduce my co-authors Mark Perez from Clean Power Research and my colleagues from Pace University, University of Rome, and URAC. The title of the presentation is A Blueprint for Achieving 100% Renewable Energy, and the subtitle I borrowed from a panel I was on a couple months ago. What steps are government taking to allow integration of renewables into the power supply? And when I was on that panel, the first thing I did was to change the wording a bit because the current steps are probably not optimal in my opinion. So let's look at the big picture. Solar and wind in green at the top are the two largest resources that could supply the earth many times over the consumption and replace the finite resources. So we have a big solution potential, and for solar the instrument of that solution is PV, and PV is getting a lot cheaper. It's probably the cheapest way to make electricity today. And this is the price of modules from 1987 when I started working, and it's not going back up. It's in the 20s per watt today, and it's going to be in the 10s per watt in a year or two, according to my friends in the industry. So we have a big solution, it's a very cheap solution, but it's not growing as fast and as smartly as it could. And there are two reasons for that in my opinion. One is intermittency, and the other one is regulation. And they kind of don't go well together. The regulations don't deal well with intermittency today and cannot grow solar where it could be. So let's look at intermittency first. That's the output of a plant on a partly cloudy day. And that's what's needed on the grid. So obviously it doesn't fit. And as a result, solar has a marginal position when what we need at the end of the day is a grid dominant position. And that marginal intermittent position, in my opinion, is at the root of the utility solar industry opposition we see today and all these assaults on, say, net metering. And that's the intraday issue with its well-known ducks growing on power curves. But that's a small problem. The much bigger problem, order of magnitude at least bigger, is the multi-day and seasonal intermittency. What we need is something that's capable of producing 24 hours a day, 365 days a year, without failing, if we are serious about replacing conventional regeneration into solar and maybe wind. So how do you transform intermittent PV into firm dispatchable 24/7? Storage can do the job, and everybody's looking at it. There is one issue with that, whereas intermittent PV is very cheap, below grid parity. Firming it up 24/7 with storage alone would be hopelessly expensive. And even considering the lease cost projection of future storage costs, that would still be way too expensive. Unless we do something that's contrarian, we overbuild PV and wind and we curtail them by design. We waste some of the output. And when you do that, and that was the major finding in Mark's PhD a few years ago at Columbia, the firm cost of energy that you see, the white line, goes down, and it reaches a point where it can be almost acceptable, near grid parity today. And you can see the contribution of PV in red and storage in blue. So PV goes up because you overbuild, but storage goes way down. It's so effective, in fact, that we started calling that implicit storage. We can back that up with high visibility studies we completed. Clean Power Research did a major study for MISO, the Mid-Atlantic System Operator, where solutions for 2040 point dominance of PV and wind at less than 5 cents per kilowatt hour. That's for 24/7 power. We looked at several islands where we also reached low level for 100% PV. And my colleagues in Italy did the Italian grid where they arrived at very similar conclusions. So technically it can be done. The thing is that the solution to get us there doesn't work today. It's not monetizable. So we are stuck here in a marginal position, an expensive position, where we could get there in a low cost and effective position capable of replacing everything. So the solution obviously is not dependent on technology, but on policy. And the first thing that ought to be done is to considering monetizing firm kilowatt hour instead of unconstrained as we have today. That means embed the storage, curtailment, and geographic dispersion that can enable that firmness into the monetization. Firm PPAs along the lines could do that. And at the same time, we would have to move away from things that remunerate all the kilowatt hours and maximize production as we have today. Things net metering as we know it, current PPAs. In New York, we have VDER, value of distributed energy resource. They're all geared on maximizing, on counting all the kilowatt hours. So we have to move away from that. Second thing is to recognize that we need firm power with respect to the grid and not to any particular user. So we have to evolve from a process today which is largely customer driven to bring the utilities and grid operators into the picture, especially as far as management is concerned. That doesn't preclude developer and customer ownership by any means. And that customer-driven to grid operator-driven process is something I lived through myself over the years. When we built our first PV system before it was even legal to interconnect in 1995, I had no idea what marginal solar was back then. I wanted to use my roof and produce my own energy. A few years ago, we graduated to a much bigger system. We have a battery, we can do arbitraging, we can be resilient, we have electric transportation, and we can brag about being net zero. And the system makes it really easy for us. We have net metering, high value, we have tax credits from New York and the feds, rebates from New York, rebates for the EVs, and everything else could be financed at very low interest. But the question to ask, is that the best way to big solar? And the answer I must give is a resounding no, a big no. Because none of those million customers you see here can do what we did. They don't have either the financial means or the space to do that. Nor can these large industrial customers. And if I solve our problem, it's a small part of what we have to do. So we have solar at the margin for some today, when we could have big solar for all. So it's not quite there yet. So how do we evolve from marginal to big solar? So first, we have to monetize firm power, because at the end of the day, we'll need firmness from solar and wind. That means embed the enablers, storage and overbuilding in the monetization. Second is to bring in the grid operator in the loop, especially as far as managing the production. And since we are talking about overbuilding PV, it's important to ask how much space we would need at the end of the day if we're going to double the space. In the US, it would be 8,500 square miles of PV, assuming twice oversizing. And I've been spending an awful lot of time lately to debunk a growing grassroots opposition opposed to PV development in the countryside. But when you put those 8,500 square miles in perspective, it's not much at all. It's a tiny fraction of the way we occupy the ground in the US. It's about the size of high-density urban development, half of the size of medium-density urban development, and about 1% of farmland. And we are using 7 times more to produce corn ethanol today. It's mind-boggling. And we're not even sure it has a positive energy return. Another thing where we don't ask about space is hydropower. We're using twice as much. We flooded ecosystems to produce only 5% of the US electricity. So think about it, producing 100% with half the space, 24/7, not bad. So the third thing we need government help with is local, state, regional planning to see where we would deploy. So we have a big solution. We have a cheap solution that can work effectively, demonstratively well, but it's in dire waiting of effective new policy and regulatory thinking to enable that potential. So this is the view of the world today. It's the same energy, but distorted. That's the view that the conventional players would like you to have. But it's also a view we contribute to by sticking to a marginal position for solar. So we have to evolve from that. And on those good words, I'll thank you for it and be ready to take any question.